Welcome to all of you. Now we discuss about MCQ of the paper CC-5 2022 Mathematics Honors Semester 3, University of Calcutta. Question paper 2022, Group A, question 1A. Let L equal to limit x tends to 0 plus square root of x minus box x and m equal to limit x tends to 0 minus square root of x minus box x. The value of L comma m is correct option is 1, 0, 1. Now box x, that is the greatest integer function, that is the floor of x, equal to minus 1 when minus 1 less than equal to x less than 0, and 0 when 0 less than equal to x less than 1. Now limit L equal to limit x tends to 0 plus square root of x minus box x. So when x tends to 0 plus, that is this. So within this x tends to 0 plus, so box x equal to 0. So this box x equal to 0. So put box x equal to 0, and 0 plus means this in this range 0 plus. So box x equal to 0 and this equal to 0. And m equal to limit x tends to 0 minus in this range. So minus 1 less than equal to x less than 0. So box is equal to minus 1. So this equal to x equal to 0 and this equal to minus of minus 1, this plus 1. Actually, by Desmos application, we get the graph this y equal to square root of x minus box x. So this is the graph this, and when the limit x tends to 0 plus, so we get value is 0, and when 0 minus limit, left hand limit, so this is the value is 1. Question 1b, if fx equal to box x square on close to interval 0, 2.5, then number of points of discontinuity of fx is correct option 4, that is 6. Now box x square, so x square equal to 0, this implies x equal to 0. X square equal to 1 implies x equal to plus minus 1, and so on. X square equal to 6 when x equal to plus minus 2.45. So if x equal to box x square, that is the greatest integer function of x square, this equal to 0 when x minus 1 less than x less than 1, because this is this, when x is equal to 1, x square is 1. X is equal to minus 1, then x square is 1. But minus 1 less than x less than 1, box x square is 0. And when 1 less than equal to x less than 1.414, then box x square is 1. As when x equal to 1.414, then box x square is 2. So this value 2. And also we get also this limit minus 1.414 less than x uh, less than 1 less than equal to minus 1. Also within this we can get box x square equal to 1, but we avoid the negative part of this region, because here only interested for the closed interval 0 to 2.5. So here we neglect the negative part of this region. Also you can get box x square equal to 1 for minus 1.414 less than x less than equal to minus 1 and this interval, and box x square equal to 2 when 1.414 less than equal to x less than 1.732, because x square equal to 3, x equal to 1.732. And also for the negative part, that is minus 1.732 less than x less than equal to minus 1.414. And similarly we get this equal to 3 for this region, the positive region, positive x for positive x, 4, 5 and 6 for this region, this. So this point for x equal to 1, we get discontinuity, x equal to 1, x equal to 1.414, x equal to 1.732, x equal to 2, x equal to 2.236 and x equal to 2.45 within this region. We get for this interval 0 less than equal to x less than equal to 2.5, we get the points of discontinuity of fx at this point 1, 2, 3, 4, 5, 6, 6. We get 6 point of discontinuity. You can get for this graph by Desmos app, the box x square floor x square function is this. And this is the graph of floor x square. And then when minus 1 less than x and less than 1, we get x, box x square is 0. And from for positive region, this 1, 1, 2, and this point is this point is 1.4, x value is 1.4, and for this point is 1, 1, 1 to 1.4, 1.4 or open interval, semi-closed interval, 1 is less than equal to, and 1.4 is the open interval, this. And similarly we get for this point from minus 1.41 to value of x less than equal to minus 1, we get box x square is 1. And for this part, 1.41 less than equal to 1.41 to up to this point 1.72, we get the box x square value is 2. And for the negative part and for this and so on, so we get this is the graph of the box x square. So for this we get for the 0 to open interval, sorry, closed interval, 0 to 2.5. So 2.5 is this here. So this point 1 is discontinuity, point this 1.4, 1.7, 1, 2, 3, 4, 1, 2, 3, 4, 5, and 6. This point is this 2.44. So less than 2.50, we get 6 points. The 1 point, this 2 point, 3 point, 4, 5, and 6. So we get 6 points of discontinuity within this limit. Question C, which one is not uniformly continuous on the indicated intervals? Fx equal to x sin x, x not equal to 0, and fx equal to 0 when x equal to 0 on open interval 0, 1. And this fx equal to 10x on this minus pi by 4, pi by 4, and this fx equal to 1 by x on 0 to 1, and this correct answer is this fx equal to 1 by x on 0, 1, 1 open interval. Because fxn equal to 1 by xn, set this in set of natural numbers, and if fx equal to 1 by x is uniformly continuous on 0, 1 open interval, then every Cauchy sequence xn in this open interval, the sequence fxn must be a Cauchy sequence in the set of real numbers R. Let xn sequence equal to 1 by n plus 1 sequence. When n belongs to the set of natural numbers n, and this is a Cauchy sequence in the open interval 0, 1. Then the sequence fxn is obviously, if it is here n equal to 1, so we get fxn is equal to 1 by xn. So 1 by xn is 2. 1 by xn is 2, and for n equal to 2, we get fxn is 3, and so on. This is not a Cauchy sequence in the R, real number R, hence it is not uniformly continuous on this open interval 0, 1. Also note that let f be continuous on an open bounded interval AB, then f is uniformly continuous on the open interval AB if and only limit x tends to a plus fx and limit x tends to x tends to b minus fx both exist finitely. Here, limit x tends to 0 plus 1 by x equals to infinity, and so does not exist finitely for this limit for the left hand point, this 0, for this 0. So fx equal to 1 by x is not uniformly continuous on the open interval 0, 1. Question 1D. If fx equal to x sine 1 by x to the power 2023, x not equal to 0, and fx equal to 0 when x equal to 0, the oscillation of f at 0 is 2. Correct option is 0. Here limit x tends to 0, x equal to 0, and sine 1 by x to the power 2023 is bounded function in some related neighborhood of the point 0. Therefore, limit x tends to 0, x sine 1 by x to the power 2023 equal to 0, that is equal to f0. Hence, fx is continuous at x equal to 0. So, oscillation of the function fx at the point x equal to 0 is 0. For continuous, if function fx is continuous at any point, then oscillation is 0. And this limit, this function fx equal to gx into hx, if hx is bounded in the some related neighborhood, and limit gx tends to 0, the product of this gx and hx limit extends to a equal to 0 from the theorem of a limit. Question E, limit x tends to 0 1 by x minus tan x by x square is correct option 2, that is 0. Here we can write limit x tends to 0 x minus tan x by x square, that is 0 by 0 form. So differentiate numerator and numerator and denominator. With respect to x, we get 1 minus sec square x by 2x, that is equal to limit x tends to 0 minus tan square x by 2x. Again 0 by 0 form. So we get, again differentiating, we get this 2 tan x sec square x by 2 to cancel. This sec square x is 1 at the point 0 and tan 0 equal to 0. So obviously the limit is 0 by L'Hospital's rule. Which of the following function does not satisfy the Rolle's theorem in the closed interval minus 1 to 1? Obviously, this function, mod x function, does not satisfy the Rolle's theorem in minus 1 to 1. Because mod x function for this at the point x equal to 1, function is continuous, mod x is continuous but not differentiable, because this left hand derivative is minus 1, this, and right hand derivative at the point 0 is plus 1. So obviously mod x is not differentiable at the point 0, but mod x is continuous at the point 0. And so the second condition of the Rolle's theorem, that is fx is differentiable in the open interval AB, is not satisfied in minus 1 to 1 because mod x is not differentiable at the point x equal to 0. Question 1G, for a differentiable function f in the closed interval 0 to 2022 with f0 equal to 2022 and f 2022 equal to 0, which of the following is true? Correct option is 2, f dash c1 plus f dash c2 equal to minus 2 for some 0 less than c1 less than c2 less than 2022. This is the x-axis, y-axis. Consider this graph, this point A, that is FA, this height is FA, and this is the y-axis, and this point B, so this height is AB. And according to our problem, this FA equal to B and AB equal to A. We choose here this 0 point is A and this 2022 is B. Say. So FA equal to B and AB equal to A, this is the condition of our problem. If f is continuous on the closed interval AB and differentiable in the open interval AB, then by Lagrange's MBT, this fb minus fa by b minus a equal to f dash c for some c within this range a less than c less than b. Set a equal to 0, b equal to 2022. So we get fb 2022 that is equal to 0 and f0 that is equal to 2022. This b minus a that is equal to minus 1. So f dash c equal to minus 1. Now we divide the closed interval AB by a point A plus B by 2 in the midpoint of AB and B. So A, comma A plus B by 2, A plus B by 2, comma B. Applying Lagrange's MPT on these two intervals, all conditions are satisfied within these two subintervals. So we get A plus B by 2 minus FA by a plus b by 2 minus a equal to f dash c1. This c1 lies in this subinterval, first subinterval a and a plus b by 2. This is the c1 in this point. And similarly, for the point c2 within the second subinterval, this is a plus b by 2 and b within this subinterval. This C2 lies between these. For this C2, we get AB minus FA plus B by 2 by B minus A plus B by 2 is equal to F dash C2. Adding these two, we get this cancel, this is equal to F dash C1 plus F dash C2. So this is equal to 2 into FB minus FA by B minus A, F dash C1 plus F dash C2. And set A equal to 0, B equal to 2022, then FA equal to 2022 and FB equal to 0. So putting all these values in this, so 2 into 0 minus 2022 by 2000 minus 0, this. So this cancel, minus 1, that's equal to minus 2 for this limit, this. Hence the answer is correct. Next question, question 1H. If Cauchy's MPT is applied on two functions fx equal to x squared, gx equal to x in the closed interval minus 1 to 1, then xi belongs to the open interval minus 1 to 1 is equal to, correct option is 2, value of xi. According to Cauchy's MPT, this is equal to a and g both continuous closed interval, fg both differentiable open interval, and g dash x not equal to 0 for all x in the open interval, and we get a point C within the open interval AB, so that b minus fa by gb minus g equal to f dash c by g dash c. Now, here fx equal to x square and gx equal to 1. So, obviously, f1 equal to 1 square, that is 1, f of minus 1 equal to minus 1 square, that is 1, g1 equal to x, that is 1, g of minus x minus 1 equal to minus 1, and f dash x equal to 2x and g dash x equal to 1. So we get fb minus fa by gb minus ga. B is here b is 1 and a is minus 1. So we put all these values, and at the point for the point C within this interval a less than c less than b, we get 2c by 1, that is c equal to 0. Next, 1I. Let fx equal to 2x plus 3, x less than 0, and minus 3x plus 1, x greater than equal to 0, then x, and then at x equal to 0, f has neither maximum nor minimum. If we draw the graph by Desmos application, and then we get, this is the for x less than 0, 2x plus 3, and for x greater than equal to 0, minus 3x plus 1. So right hand limit for x equal to 0, x tends to 0 plus, we get this 1, and limit, left hand limit of this function is equal to 3, and the value of the function at the point 0, f0 equal to 1, because x equal to 0 here. So if x is not continuous at x equal to 0, and obviously f has neither maximum nor minimum at x equal to 0. Actually, in this problem, maximum value is 3, but not here. 3 not here, this. So attend to 3. If this is attend to 3, then maximum value is 3. But this is the limit 3, not value of the function not equal to 3. Question J. Suppose f be differentiable function in R such that f dash is monotone, then which of the following is incorrect? F dash is continuous in R. If dash is monotone, correct option is this. If f maps from closed interval AB to R differentiable on the closed interval AB, then the derived function f dash cannot have a jump discontinuity on the closed interval AB. This is the schema of page number 321. And the theorem, if f is differentiable function in R such that if this is monotone, then f dash is continuous in R. So this function is, if dash is continuous in R differentiable function, then this is true value, not as incorrect. This the point is incorrect. If dash is continuous, so if may be supremum in R, if may have infimum in R. If may be, this is the correct, not incorrect. If dash is continuous in R is correct option. If dash is continuous in R, differentiable R, if may have supremum in R, yes. If may have infimum in R, if dash may be continuous in R, not maybe. So its incorrect answer is f dash may be continuous at 0. No. F dash continuous at 0, not maybe. So correct answer is here f dash may be, because this incorrect option, f dash may be continuous, not maybe. F dash is continuous in R, so obviously f dash is continuous at also 0. So incorrect option is this. So actually, so we avoid this term incorrect. So for incorrect answer is this. If dash may be discontinuous at that, so not maybe. So this is incorrect. If dash must be continuous at 0, not maybe discontinuous, not discontinuous at 0. So this is correct option is, incorrect option is this 4. If dash may be discontinuous at 0. Here we, this is the correct option. If dash is continuous in R, this is the, if this question is then which of the following is correct, then this is the correct. If dash is continuous in R, but it is incorrect. So if dash may be continuous in R is the incorrect option. So right answer is 4. Right option is 4. So here right option is 4. If dash may be discontinuous, may be continuous in R, not maybe, surely continuous actually. Thank you for watching this video.